Here's another video on Garobi optimizers and linear programming. This time I'm bringing a script to the table that's essentially a replication of the script that is in the GitHub repository. I do take some time to break down what's going on in my own words, and this is an example of how linear programming can be used to be solving difficult problems. I love this optimization package so much, I actually bought the textbook. If you go on Amazon, you can find it. It's called Model Building and Mathematical Programming. It's about 56, $60. But there's a little tip. If you go to this website called Thrift Books, you can get it for like $15. I'd recommend going to Thrift Books because you're going to thumb through it a few times, have it, and then throw it in your library to reference when needed in the future. This problem that we're laying out is essentially a factory constraint problem. We're trying to understand with the machines that we have, the downtime that they have, and the demand that we need to meet, how can we maximize our given profit? Very difficult problem to solve because there's so many different variables and a lot of different sort of things occurring all at once. It's tough to understand, well, what do I need to produce when? How much storage should I have? And then what should I sell to meet that demand at any given moment? So in this code right here, what we do is we try to lay out the introduction and the problem description that I just discussed. I tried to explain how many of each piece of machine that we have. So think you're a small machine shop, you have only so many machines, you can only run them for so long, as well as you have only so many hours that you can run them every month. From that, we have a constraint of how much storage capacity we have for a given product that we can put in our warehouse, as well as making sure for the following planning period we're set up, and that meaning that we needed 50 given units. We have inventory holding costs, which I think is pretty like 50 cents per unit if we store it. So, inventory's not free. So we needed to take that into account. So that's going to be taken into account for our profit simulation. And then further laying out what the overall problem is. I'll leave this in the post that I put, so you can go ahead and pull this up and reference it yourself if you'd like. But essentially, first that you have to do is you have to install Garobi Python. Now, this optimizer model is free for sort of ideas like this, but if you're going to use this at scale, you have to actually reach out to the Garobi team, and then they'll give you a price or a license that you can use to use this modeling in your own given business. There are free options, things like Pyomo and Solver. Solver is built right into Excel, so that's pretty cool, but there are constraints when your models get too big and complex. Solver has a hard time computing all that. Pyomo is great. I just find Garobi's documentation to be quite a bit better. And that's just more mainly probably a personal preference. But first, we just install the package like we would normally, and then we just sort of import some common packages in here. And then I go through and build out the problem statement using lists and dictionaries. If you're unfamiliar or uncomfortable with lists and dictionaries in Python, there's a great course on Udemy by Angela Yu. It's called 100 Days of Python, and this is one of the early concepts that she sort of touches on. I think it's important to understand if you're working with Python on a daily basis, how this looks, maybe not even for just writing the syntax, but being able to read it and interpret what's going on. Essentially, all we're doing is taking that above problem statement and modeling it. So when the Garobi tool can receive this and then begin to work the numbers and provide the output, but nothing too special really here. It's just restating the problem statement. And now the more difficult piece, still relatively simple when it comes to syntax, is building out the model. So first and foremost, we say that the factory is the model that we're going to solve for, and we're going to build out. But we need to determine what those decision variables are. So we need to know what we need to make, how much we need to store, and what we need to sell on a given month. So we're just building those conditions into our problem statement. The constraints I discussed, those are essentially walls in which we cannot go over or go around. Like these are things like hard stop, you need to have 50 items of inventory on hold at the end of the planning period. So June, you need to have 50 across the board. You start with 0, things like your hours, and then the understanding that you have so many hours of machining that you can use, and you can't go beyond that because there's only so many hours available. So these are the sorts of things that you need to understand. Your ERP system should hold a bit of this, and the other areas you can sort of, if you don't know it, you can swag it, based on how complex or easy you want to make the problem. Just understand every single constraint that you add to a problem reduces the optimal solution. So the more constraints you add, the less optimal your solution will be, but it might mimic a bit more reality. Additionally, these are to give you a really good idea of what you need to do, but there's always things that come up in real life. So you try to meet this objective and try to meet these goals to give you an understanding of what you may end up at, but there's red herrings that are thrown in all the time. Maybe your machine's down longer than you anticipated. That's going to definitely throw a wrench in the overall problem. So we'll go ahead and run the balance constraint. We also have a target that we need to be at for our inventory, which I talked to you about that June 50 by the end of June. We have hours constraints for machines, and all we're doing here is essentially just a for loop that says, hey, the hours that we assign to our machine has to be less than or equal to the hours that are actually available with our downtime taken into account as well. The objective is a maximization of profits. So essentially, we're just building that function here, essentially saying the profit for each product times the amount that we sell minus our costs. And then it's a GRB maximize. You can also do minimization functions. So if you're trying to figure out a problem for the minimum cost to produce XYZ or to do XYZ or to improve time throughput for logistics, whatever we're trying to model, you can use maximizations and minimization functions. And then we go ahead and run the model. So here I'm just trying to explain what the output of this is going to be, but we'll just go ahead and run it down here. You can see at the very bottom of this, I'm sorry, I've got a bit of latency, that's why it's struggling. But the objective that we are trying to solve, the answer is 9.37 e to the fourth. So it's essentially saying that our profit is $93,715.18 if we do what the model says that we should do. But what does the model say that we should do? So we have to essentially pull that out of the decision. So remember earlier we described what those variables were of make, plan, and sell. Now we're just going to say, hey, Garobi, what did you say we needed for this? So use the .x attribute to say, hey, Garobi, tell me what you said for this product month combination for this variable of make, sell, or buy. And then let's go ahead and turn that into a pandas data frame. We just do it in a really clean, concise syntax. I actually like how the tutorial sort of wrote it out because I thought it was really clean and easy to understand. And then it just tells you the plan that you need to follow. So if you're in production now and you're say a manager or somebody that's running the line, you're like, oh, I need to be able to produce this many items. So you go ahead and do that. Maybe in your S&OP meeting, you're sitting down and you're saying, okay, we need to produce this many items. And oh, by the way, our marketing team, we need to sell this many items to meet our objective. And by the way, the supply chain team, make sure that we have capacity to store this many items in the given product. And it becomes less around all of the code that we've written out here. Of course, that's important for your data team to understand and make sure it's accurate. But the conversation starts to shift towards these three tables. Think about it. You're in that session, you have three tables. You say, is there anything at this model? Excuse me. Excuse me. Is there anything in this model that we can't achieve? Now that is data making decisions for your business. And that is the power of linear programming. This is one of the coolest concepts I've come across in data science world. I mean, of course, the AI, machine learning, all that's really interesting. But when it comes rubber meets the road and I'm going to make a decision in operations, this right here has so much untouched capability for like optimizing, not leaving anything on the table for when you're building your business. And it brings away intuition and starts to challenge that intuition and say, am I doing things in the most optimal fashion? Thanks again. Worked really hard on this today, from the burrito truck, if you watched my video earlier, to this. I know I ran through it relatively quickly. Just a fun thing to learn and to know and to have in your quiver for when you're at your work.